Welcome back. Last time we used line stats to calculate the slope, the intercept, and the uncertainties. This time we're going to do a little bit of probably grade 10 advanced maths linear equations to add in our max and our min lines over here on the chart. Let's have some theory first. So just going to put a return there to separate that out a bit to make it easier to read. So here we go. If I've got gradient, B is the gradient, with an uncertainty, that's the same as a difference in two y coordinates divided by a difference in two x coordinates. Now, I know x bar and y bar, the mean value, has to belong on any regression line I draw. That's like when I used to put my pencil there and pivot the ruler when I did these by hand as a student myself. Now, I know the value of x bar and y bar, that's on my spreadsheet. I know the gradient, and I know the uncertainty in the gradient. That's on the spreadsheet as well. This k is a scaling factor which will allow me to adjust the width of the max and min lines. Now I'm going to multiply the x take the x bar against all of this, so that's in brackets times x take x bar. That would leave me with y take away y bar, and then I just add on y bar, the average y value. So I know the gradient, I know the uncertainty, I know x bar and y bar. For any x value at all, I can predict the y value that will belong. Now that's a pretty complicated little formula there. So I'm just going to take a small screen snip of that formula, and I'm going to go back to my other tab, and I'm going to just drop that on the page so I can see what it is and I don't forget what I'm doing. Now this one was for the max. So I'll come in here to the max and I'll start my formula. It says, first of all, B. Now that's the slope, and I'm going to lock that in with dollar signs for an absolute reference, plus my scaling factor K, which I currently have set at 3, again locked it in, multiplied by the uncertainty delta B, that's this one, once again locked in, close the brackets, multiply by, and now I'm up to x take away the mean of x. That's the x coordinate, and I'm not locking that one in because I will copy this formula down, and take away the mean value of x, always the same mean value, close those brackets. Now I'm up to plus, add on the mean y value, again lock that one in. Pause here for a moment and look carefully at that equation that I've typed in Excel here to convince yourself that it accurately represents that little bit of linear mathematics, linear function mathematics. Now that's the hard work done. Copy that down. Remember, paste formula. Those x coordinates are predicting these y coordinates if I was to use the maximum possible gradient, which is in my case 4.023 plus 3 times the uncertainty. The 3 doesn't have to be 3, it could be 1. Did you see how they all changed? So that would be as if I had 4.023 plus 0.003. Now, we'll do a very similar process for the minimums. Here's the theory for the minimums. The only difference is there's a subtraction sign there. So it's the predicted gradient, subtract the uncertainty. But the rest of this is the same. So I'm going to do the formula here. It will be gradient, fixed, this time minus scaling factor, multiplied by gradient uncertainty, close the brackets, x, subtract the mean value of x, and then add on the mean value of y. Once again, pause for a moment and convince yourself that that formula matches that one, except with a subtraction instead of an addition there. Copy that. Highlight the remaining cells and paste the formula in. We're going to quickly add these extras as trend lines in our chart. So we've done this before. Click the chart, chart design, select the data, add a series. The X values are the same X values we've used all along. The Y values, let's the first one be the minimums. Now I'm going to add another series. Don't worry about the chart, it'll reset nicely in a minute. X values, and the Y values this time will be the maximums. Now I've got these extra dots appearing. That'd be series 3 and series 4. I could try to click on them, but it's a bit hard to click on exactly the right object when they're so crowded. So instead, I'll simply click on the chart. From the Format tab, I will select series 3, and then I'll press Format. Now it's all about appearances, so I will have no solid line. That's not what I want. I do want a solid line. I think I'd prefer it to be orange to contrast, reasonably thin, and dashed. As far as markers are concerned, I'll have none. And that should be formatting series 3. I've still got some dots there for series 4, don't I? Let me go here again and do this to series 4. Format the selection, its appearances, no markers, solid line, beg your pardon, that's wrong, that's still markers, I need to be over here on line. Solid line, a little bit thinner, and dots. Now, with a scale factor of 1, these uncertainty lines are very, very close to the actual trend line. You can barely see some orange dots. And they don't seem to really be matching the size of the error bars up at this end of the graph. So I can control that with the scale factor. Do you see when I put a scale factor of 3, it literally means I'm tripling the uncertainty to about 0.099. Now that's a judgment call. This is like when I used to pivot my ruler against my pencil to decide where the appropriate max and min line would go. It's probably still a little bit too close. The max and min, the orange dotted lines, still are a little bit too close compared to these error bars here. They're not too bad down that end. I might bump that up from 3 to 5. Do you see how they've widened out a little bit there? And they're not too far past here. I think I'm happy with that. That, to me, I think, is a better representation of the max and min line. Now, that chart is finished. That chart is presentation quality, ready to be cut and pasted into my experiment report. That's a bit of a long one, this one, so thanks for sticking with me, and I'll see you next time.